there are three laws of planetary motion by Kepler. The first law is that each planet revolves around Sun in an elliptical orbit with the Sun at one of the foci. Okay, and the second law is that the line joining the planet to the Sun. Now you can see this is the line. Okay, this line joining the planet to Sun, it sweeps out equal area in equal intervals of time. So can you observe this one? At some point Earth will be very close to Sun. At some point Earth will be far away from Sun. Okay, so but the area swept means suppose right now here. Okay, then afterwards it reached here. Then area swept will be this much area between these two lines. According to Kepler's law, this area will be same throughout the year in equal intervals of time, whether the Earth is very near to the Sun or it is far away from the Sun somewhere here. The area swept by the line joining Earth to Sun will be same in equal interval of time. And how it is possible, you know, that is very wonderful thing that I can explain in detail only in another lesson of rotational motion. I will explain in short. That is, this is possible means the line joining the Earth to Sun, it sweeps out equal area in equal interval of time. It means when the Earth is revolving, when the Earth is moving very near to the Sun, speed increases, it speed up. So it will cover more distance, correct? When the Earth is near to the Sun, it start moving very fast, so it can cover more distance. When the Earth is away from the Sun, it moves slowly, it slow down. So it will cover less distance, but area will be same because this much long distance is there. So if it moves very less distance on the orbit also, the area swept will be very large because from here to here, distance is very large. If Earth is moved from here to here also, the distance, the area swept in this gap will be very large. According to Kepler's second law, the line joining the Sun to the Earth sweeps out equal area in equal interval of time. That is possible because when the Earth is closer to the Sun, it move fast. It move fast. When the Earth is away from the Sun, it moves slowly. Suppose Earth is right now here. In 1 hour, it moved to here. So what is the area in between these two? The area swept by this line in 1 hour. That will be constant throughout the year. Whether the Earth is closer to the Sun or it is far away from the Sun, it will be same. It is possible by adjusting the speed of Earth. So don't think that Earth is moving with a constant speed. When the Earth is closer to the Sun, it moves fast. It moves fast. And when the Earth is far away from Sun, it moves slowly. And how it is again possible, that I can explain only in another lesson of rotational motion. It is possible. Okay. Now see, the time period of square of the time period of revolution of a planet is proportional to cube of the semi-major axis of the planet. That is Kepler's third law. Time period of revolution means suppose Earth is the planet, then what is the time taken by Earth to complete this revolution around the Sun in an elliptical orbit? For Earth it is 1 year, isn't it? 365 days. Okay. So 1 year is the time period of Earth to revolve around the Sun in this elliptical orbit. To complete this one revolution, Earth will take 1 year. That is time period of Earth. And A cube means A is the distance between the average distance between the Sun and Earth, or it is the semi-major axis of the elliptical orbit. For Earth, small a will be equal to 1.5 into 10 raised to 11 meters. Okay. So this is called Kepler's third law. Okay, now suppose we have two planets. We know for first planet Earth, we know the time period and we know the semi-major axis, the average distance between the Earth and the Sun. Suppose we have one more planet, that is, it has time period T2. Suppose the time period we are calculating by observing the planet every day, and we can find out the time period observing by watching the sky. But we don't know its distance. What is the distance of that planet from the Sun? A2 we don't know. Now we have two equations. Suppose I am taking this as equation 1, this is 2. Then if I divide equation 2 by 1, I can write T2 square divided by T1 square. Then proportionality constant, when I write equal to here, the proportionality constant will be same for both, that will get cancelled. So I can write here A2 cube divided by A1 cube.
A1 cube.
In this T1 is the time period of Earth, we know that it is 1 year. A1 is the distance of the Earth from the Sun, that also we know it is 1 astronomical unit. T2 is the time period of any unknown planet, some other planet, suppose Jupiter. Find out T2 value by observing the sky, but we don't know the distance A2. So if you know T1, A1 and T2, we can calculate A2, isn't it? This is the method used for calculating or measuring the distance of superior planets which are revolving outside the Earth. Okay.